Hello, my dear boys. Welcome to my online class. In this class, we will discuss about some necessary equations to solve mathematical problem on effects of heat on matter, and we will try to do a mathematics on this chapter. So, our first formula was Tc by the relation among the three scale of temperature. The relation among the three scale of temperature is Tc Tk minus 273.15 divided by 5 equal to Tf minus 32 divided by 9. Here Tc stands for Celsius temperature, Tk stands for Kelvin temperature, and Tf stands for Fahrenheit temperature. Our number 2 equation was the coefficient of linear expansion. The coefficient of linear expansion is alpha equal to L2 minus L1, L1, T2 minus T1. From this equation, we can also write that L2 minus L1 equal to alpha L1, T2 minus T1. Okay. Again, we can write that del L equal to alpha L1 T2 minus T1. Okay. Our next formula is number 3. Expansion of coefficient of Aelia expansion. Coefficient of Aelia expansion is denoted by beta equal to A2 minus A1 into T2 minus T1. Again, we can write for this formula is A2 minus A1 equal to beta A1 T2 minus T1, or we can write del A2 equal to beta A1 T2 minus T1. Again, we have another coefficient of expansion, and that is coefficient of volume expansion denoted by gamma equal to V2 minus V1 T2 minus T1. So we can write V2 minus V1 equal to gamma V1 T2 minus T1. So from this line we can write del V equal to gamma V1 T2 minus T1. Okay, this is our equation number 4. And the equation number 5 is the relation between among the coefficients. The relation among the coefficients. The relation between linear and area coefficient is beta equal to twice alpha, and the relation between linear and volume expansion is gamma equal to thrice alpha. Number 6 formula, the specific heat. The number 6 formula VL, real volume VL equal to real volume equal to apparent volume plus volume of bulb. Okay. Number 7. The number 7 is the specific heat. The specific heat is denoted by S. equal to Q divided by M into T2 minus T1. Okay, and the final equation, again 8, the heat capacity divided by C is, we can write T equal to T2 minus T1, and our final equation is the fundamental principle of calorimetry, and that is the heat given up equal to heat gain. Okay. Using these equations, we will try to do some mathematical problem. At home, you need to do more practice. This chapter is very, very important for final exam. Okay. Then let's do a mathematical problem. Let's solve a mathematical problem. And the problem is a piece of ice of mass 100 gram is dropped into water of 1 liter at temperature 30 degree Celsius. Okay, what will be the temperature of the water after melting the whole piece of ice. Here given that the latent heat of ice L equal to 334 kilojoule per kg. So our mathematical problem is a piece of ice of mass 100 gram is dropped into water of 1 liter at temperature 30 degree Celsius. What will be the temperature of the water after melting the whole piece of ice? They are given that the latent heat of ice is M equal to 334 kilojoule per kg. Okay, let's solve the mathematics. Solution. First of all, we need to identify the given terms. Here, the mass of ice M1 equal to 100 gram equal to 0.1 kg. Mass of water M2 equal to 1 kg. Here 1 liter is equivalent to 1 kg. Okay. Specific heat of water, we know that specific heat of water is W equal to 4200 joule per kg per Kelvin. Okay. Let here you will see that the temperature of the ice is not given. The temperature of ice is not given. So we can let the temperature, though it is a ice, so we say that the temperature of ice is 0 degrees Celsius. Okay. So let us assume the temperature of ice is 0 degrees Celsius and the final temperature of mixture is T. Okay. Here the given mass of ice is M1 equal to 0.1 kg, mass of water M2 equal to 1 kg. Here 1 liter is equivalent to 1 kg. Okay. Specific heat of water SW equal to 4200 joule per kg per Kelvin. And let us assume the temperature of ice is 0 degrees Celsius and the final temperature of mixture is T. We need to determine this final temperature. Okay. Here we need to understand the steps. Okay. We know that heat is transformed high to low heated area. Okay. Here ice will gain the temperature and the boil water or the water will decrease its temperature. Okay. So we can say that heat will gain by ice and heat will give up by water. Okay. Then they will comes to an common temperature and that is T. We need to determine this common temperature. Okay. That's it. Then our first part is heat gain. Who will gain heat? Here from our stem we say that ice will gain heat. But the gaining of heat will be in two parts. The first part, in our previous lecture we said that the ice will not direct convert into water. The 0 degree temperature ice will convert into 0 degree Celsius temperature water. So in this stage the ice will gain a latent heat. Okay. So for this stage required to melt equal to ml. Okay, and the other part then the 0 degree Celsius temperature water will increase or will transfer up to T degrees Celsius temperature. On this stage the heat required to increase the temperature from 0 degrees Celsius to T after melting is equal to m S water T to 0. Okay, so heat gain, we will discuss heat gain into two parts. Number one part is heat required to melt the ice, and in this stage the heat gain is ml, and the other stage the heat required to increase the temperature from 0 degree to T after melting is mSW into T minus 0. Okay, here the other part is heat given up. Heat will given up by water. The 30 degrees Celsius water will transfer to T degrees Celsius temperature water. So in this stage the temperature will give off heat. Okay, so heat give off by water is equal to m2 water, here 30 minus T. We can use here the Celsius scale because here the temperature is in difference. Okay, so we can use here degree Celsius as well as Kelvin temperature. Okay, so we know from the fundamental principle of calorimetry is heat gain equal to heat given up. So we can write m1L plus m1 SWT equal to m2 SW 30 minus T. So this is our final formula, and we need to determine the temperature T. So m1L plus m1 SWT equal to 30 into m2 SW minus m2 SWT. So therefore we can write that 30 m2 SW minus m1L divided by m1 plus m2 into SW. So we can write 30 into m2 4.2 into 10 to the power 3 minus 0.1 into 334 into 10 to the power 3. Here latent heat is in kilojoules, so we need to convert it joule unit by multiplying by 1000. Okay, now 1 plus 0.1 into 4.2 into 10 to the power 3. So by calculating we get 20.04 degrees Celsius. So by calculating we get T equal to 20.04 degrees Celsius. Therefore we can say that the temperature of the water after melting the whole piece of ice is 20.04 degree Celsius. So this is our answer. Okay, this is all from for today. In our next class we will discuss about creative question. Okay, until then, thank you guys.